Hello everyone, my name is Alex Gaspar and today I'm gonna solve exercise 4.3.9 of the textbook. So they're giving us two graphs in this problem. They're giving us f of x and g of x. And on A, they're asking us to determine the exact value of the integral from 0 to 1 of f of x plus g of x. In other words, in simple words, they're just telling us to find the area of from 0 to 1 of f of x and gx and just add them up. So in order to do that, first we need to take the integral of f of x from 0 to 1 and then the integral of g of x from 0 to 1. So we do it like this. So we have the integral of 0 to 1 of f of x dx, which is equal to, if y'all can notice, the area from 0 to 1 on f of x is just a triangle. So we're just gonna use the triangle area to take this area, which is base times height divided by 2. So the base here is 1, the height here is 2, we're just gonna divide it by 2, which is just gonna be 1. So the area of this triangle is just gonna be 1. Now we are gonna do the same thing and wanna find the area of this, which, if y'all can notice, it's just 1/4 of the circle. So we're just gonna use pi r squared to find the area of the whole circle and divide it by 4. So the integral of from 0 to 1 of g of x dx is gonna equal to pi r squared divided by 4, which is gonna give us the area of the function between 0 to 1, which is gonna be pi times the radius, which is 1 in this case, square divided by 4, because it's 1/4 of the circle, which is gonna give us approximately, it's just gonna give us 0.785. Notice that the area of g of x is below the x-axis, so which means the area is also gonna be negative. So it's actually gonna be negative 0.085. So now that we have the area of both, we're just gonna add them up. So the integral of 0 to 1 of f of x plus g of x dx is gonna equal to 1 plus the area, which is in the negative side, so it's gonna be minus 0.785, which is gonna equal to 0.21. So there's the answer of A. Now on B, they're asking us to do the same thing, but this time they're asking us to integrate from 1 to 4 and to multiply f of x 2 times and subtract it the 3 times the area of g of x. So what we're gonna do first is obviously find the area of f of x from 1 to 4, which is from here to here. So let me write it down. So we're gonna find first the area, which is the integral of from 1 to 4 of f of x dx, which is gonna equal to, notice that here we have two two geometrical figures, which is the triangle and trapezoid. So to find the integral of this, we're just gonna add the area of this and this. So we have again a triangle here, so we're just gonna do the same formula. The base is gonna be 0.5, the height is gonna be 2, and we're gonna divide everything by 2. And we're gonna add the area of the trapezoid, which we know is gonna be a negative area since all the trapezoid is below the x-axis. So to take the area of a trapezoid, we're just gonna take the average of the bases and times it with the height. So the first base is 2.5 plus 1 divided by 2 times the height, which is also 2. So here's the area of the integral from 1 to 4 of f of x, because here the triangle is this and the trapezoid is this. So if we add everything up, it's negative area. So it's gonna be 0.5, because we cancel this out, plus we cancel this out too, minus 3.5, this is negative area, it's gonna equal to -3. So this is the area of the integral from 1 to 4. So this is this, okay? So now we're gonna do the same thing, but for g of x. So the integral of 1 to 4 of g of x dx is gonna equal to, notice that we have a, so here we have 3 geometrical figures. We have from 1 to 4, we have a triangle, we have another triangle, and we have a circle, a 1/4 of a circle. So now we're gonna add this. So we're gonna add, the first triangle is gonna be, the height is 1, and we're gonna multiply it by 1/3, which is the base. How we know this? Because it has a slope of 3. Because look, 1, it goes 1, and it goes up 3. 1, 2, 3. So here's 1/3, 2/3, 3/3 to this point. So you know here's 1/3, and we're gonna divide it by 2. This is the area of the first triangle. Next, we're gonna add the area of the second triangle, which is, if here's 1/3, we know that here's 2/3, because here 1/3 and this 2/3. So it's gonna be, the base is gonna be 2/3, times the height, which is gonna be 2, divided by 2. I forgot to mention, but this triangle, the small triangle, since it's below the x-axis, the area is gonna be negative. And finally, we're gonna add the area of the quarter of the circle, which has a radius of 2. So it's gonna be pi times 2, which is the radius, squared, divided by 4, which, adding all this up, is gonna be, we're gonna have -1/6 plus there of this, which is gonna be 2/3. Sorry, because we cancel all this. 2/3 plus pi pi, because this the square the 2 to the 2 is gonna be 4, so we cancel this. This is gonna be pi, which is equal to 3.1416 approximately. So if we all add all this up, it's gonna be 3.64. So now that we have the area of both, we're just gonna plug it into the function. So they're asking us for the integral of 1 to 4 of 2 times f of x, which we find that is -3, minus 3 times the function of g of x, from which we found that is 3.64. So dx. So we found that this is gonna be -6, and it's gonna be minus $10.92 approximately, which is gonna add up to -16.92. So this is the result of the integral of 1 to 4 of this.